In this slide, we will learn about velocity time graph. The case 1 is when a body is moving with uniform velocity. What you mean by uniform velocity is the same velocity throughout. So at time, say 0 second, it will have a velocity maybe 15 meter per second. At 1 second, again 15 meter per second. At the second also 15 meter per second. Third second, 15 meter per second. Fourth second, 15 meter per second. And fifth second, also 15 meter per second. Here the velocity is uniform, it's the same. So this is the velocity time graph. We take velocity on the y-axis, and velocity is measured meter per second. Time is taken on the x-axis. Now we go ahead and plot the points. So at 0 it is 15, which means at 0 it is 15. Here would be the first point. Second, at 1 second it is 15. So 1 second is here. This is 1 second. It is 15. So the point would be somewhere here. Next reading at 3 seconds, also 15. It's moving with uniform velocity. So 3 seconds, also 15. And 2 seconds was 15. Then we go to 4 seconds, 15. So this is now 4 seconds, 15. And now 5 seconds to also 15. 5 seconds, 15. And if we join these points, we get a straight line. So this is a graph of a line of a body in uniform velocity. Here the velocity does not change. It remains the same. Velocity does not change. Remains constant. Case 2, when a body is moving with uniform acceleration. So here we have a table of velocity of a body at regular intervals. Let's go ahead and draw the graph. We are drawing the velocity time graph. So this is the velocity time graph. We take the velocity on the y-axis. Remember, velocity is meter per second. Time on the x-axis, measured in seconds. In the first case, time 0, distance, it should be velocity, not distance. So we just cancel this, and this should be velocity, not distance, because we are plotting velocity time graph. Let's go over it again. Time 0, velocity 0, and that point would be out here. Next we have time 5, velocity 10 meter per second. So time 5, velocity 10 meter per second. Next time 10, velocity 20. So time 10 along this line, velocity 20 would be along this line, they would meet here. Next 15, time 15, velocity 30. So time 15, velocity 30. So that point would be somewhere out here. Next 20, 40. So this is 20 and velocity 40. Last is time 25, velocity 50. So 45 and 50 would be somewhere out here. Now that we have the points, let's join the points here. And this would be the graph. You probably have to shift the points. If you do it on the graph paper, you'll get it right. So here's a graph, velocity time graph of uniform acceleration. Now what is uniform acceleration? When the velocity increases by equal amounts. There's an increase in velocity by equal amounts in equal intervals of time. That would be uniform acceleration. Here the velocity time graph is a straight line for uniform acceleration. Velocity increases uniformly, equal amounts in equal intervals of time. Now we get on to case 3, when a body is moving with a variable acceleration. So this is the velocity time graph. So we have velocity taken on the y-axis, meter per second, time taken on the x-axis in seconds. So we'll have 0, 1, 2, 3, 4, 5, 6 seconds. Here we take meter per second, 2, 4, 6, 10, 12, 14, 16, 18, 20. Now we go ahead and plot. Now remember, this is not distance versus time, but it is velocity, so we got to change this. And not meter, meter per second. So the first point is 0 time 0 velocity. So the point would be somewhere here. Then we have time 1 and the velocity 5. So here is 1, time 1, and velocity 5 would be somewhere here. Next, time 2, velocity 8. So time 2, velocity 8. Next, time 3, velocity 14. So time 3, 14. So 14 is here. Next, time 4, velocity 16. So time 4, velocity 16. Next, time 5, velocity 20. So time 5, velocity 20. And that would be somewhere here. I think it would be here. And if you notice now, it's not a straight line, it's like a curved line. So this is non-uniform acceleration. And what is non-uniform acceleration? Is when the velocity changes. But how does it change? It increases. In this case, it increases by unequal amounts in equal intervals of time. So that's why we call it non-uniform acceleration, because the velocity does change, but by unequal amounts in equal intervals of time. That's non-uniform acceleration. Now in case 4, we draw a graph of a body moving with uniform retardation. Retardation is when there is a decrease in velocity. We'll draw the velocity time graph, the time on the x-axis, which is in seconds, and velocity on the y-axis in meter per second. We take this as 1 second, 2, 3, 4, 5, 6 seconds, and so on. The velocity will take as 5 meter per second, then 10 meter per second, 15 meter per second, 20 meter per second, and 25 meter per second. And we'll begin to plot the graph. The first reading is 0 to 25. Time 0, velocity 25, and that would be at this point. Next we have time 1, velocity 20. Have you noticed the velocity is decreasing? So time 1, velocity 20, and it would be at this point. Next is time 2, velocity 15. So time 2, velocity 15, and the point would be somewhere here. Next we'll take 3 and 10. So 3 and 10, and now the point would be somewhere here. Next we have 4 and 5, 4, and then this is 5. For the last time 5, velocity 0, and that point would be out here. I will join the points. Have you seen here the velocity is decreasing? So this would be the graph of uniform retardation. It's retardation because the velocity is decreasing. But how is it decreasing? The velocity decreases by equal amounts. By equal amounts in equal intervals of time. Intervals of time. So this is a graph of uniform because it decreases by equal amounts in equal intervals of time, and retardation because there is a decrease in velocity. So case 5, when a body is moving with non-uniform retardation. Retardation means there is a decrease in speed. Non-uniform means unequal decrease at equal intervals of time. So here is the table, time versus velocity. Let's go ahead and draw the graph. So this is the velocity time graph. Let's start plotting the point. Time 0, velocity 22, and that would be a point out here. Next, time 1, velocity 18. So time 1, velocity 18. Next, time 2, velocity 12. So time 2, velocity 12, and that would be somewhere here. Next, time 3, velocity 6. Time 3, velocity 6. Next, time 4, velocity 4, and that would be somewhere out here. 5, it should be here. Now if you join these points, it's not a straight line. It will be like a curve. So this is non-uniform motion. Non-uniform retardation. If you notice here the difference is 4, here the difference is 2, here difference is 6, here difference is 6, here difference is again 4. So the difference is different. So it is non-uniform retardation. It's not a straight line. So it would be something like this. A non-uniform retardation would be something like this, where it is not a straight line. Here are some graphs, distance time graph. Let us try and find out what is the type of motion. It is a straight line in this case, so equal distances in equal intervals of time, and this is uniform motion. In the second graph, we see it is not a straight line, the distance time is not straight, so this would be non-uniform motion. And what is non-uniform motion? Unequal distance in equal intervals. In equal intervals of time. And what is uniform motion? would be equal distance in equal time. And for the last, here we see it is a straight line parallel to the x-axis. And if this is the case, we know it is a body at rest. Now we'll take up again some velocity time graph. In the first case, we see it's a straight line parallel to the time axis, which means the velocity is remaining constant. So here the acceleration is 0 because there is no change in velocity. Acceleration 0, velocity constant. It is not a body at rest. Remember, it is moving with a constant velocity. In the second graph, the velocity is increasing uniformly. It's a straight line. So velocity increases uniformly. And if velocity increases uniformly, it must be uniform acceleration. In the next one, also the velocity increases uniformly. And hence this also is uniform acceleration. But what's the difference between these two graphs? Here see the body starts from rest. Here body starts from rest. Look in the next case. The body does not start from rest. Body has an initial velocity. Starts with initial velocity. So I wouldn't say starts, a body has initial velocity. The u is not equal to 0. In this case, u is equal to 0. Now in this was the second case, this was the third case, now we go on to the fourth case. Here there is retardation, there is a decrease in velocity. So there is a retardation, but uniform retardation, it's a straight line. Equal amounts in equal intervals of time, the velocity decreases. There is a decrease in velocity, but equal amount in equal time. In the next, we see here the velocity also decreases, but unequal, non-uniform. So this is non-uniform retardation. Decrease, but non-uniform. Velocity decreases, but unequal amounts in equal intervals of time. That is non-uniform retardation. Here's a little correction. This should have been velocity and meter per second.